Snowstorms are a captivating spectacle of nature, transforming landscapes into pristine wonderlands. But have you ever wondered how these mesmerizing events unfold? The science behind snowstorms is a captivating tale of temperature, moisture, and wind all playing a crucial role in their creation. The first ingredient in this recipe for a snowstorm is cold air. Temperatures need to be below freezing, that's 32 degrees Fahrenheit or 0 degrees Celsius for snow to form. This is because snow is made up of ice crystals, and ice crystals can only form when water freezes. The second essential ingredient is moisture. Even if the air is cold enough to snow, there won't be any snow without moisture. Moisture in the air is called water vapor. When warm, moist air rises and meets the cold air, it begins to cool down. As the warm air cools, the water vapor inside it condenses. Condensation is the process of water vapor changing back into liquid water. As the rising warm air continues to cool in the presence of cold air, the water vapor condenses into tiny water droplets. These droplets are so light that they float in the air, forming clouds. However, these water droplets don't immediately freeze. Inside the cloud, the tiny water droplets bump into microscopic dust or pollen particles floating in the air. These particles act as seeds for ice crystals to form. When the temperature is below freezing, the water droplets freeze onto the particles, forming ice crystals. These ice crystals are what we know as snowflakes. As more and more water vapor freezes onto the ice crystals, they grow larger and heavier. While cold air and moisture provide the building blocks for a snowstorm, it is the wind that ultimately shapes its intensity and path. Winds play a critical role in lifting the moist air high into the atmosphere, where it can cool and condense into snow-producing clouds. These winds can transport vast amounts of moisture-laden air over long distances, fueling the growth of snowstorms. As winds intensify, they can cause heavy snowfall rates and create blizzard-like conditions. The direction and strength of winds also determine where the heaviest snow will fall. Winds can create areas of convergence, where air currents collide and force air upward, leading to enhanced snowfall. Section 4. Snowdrifts and accumulation. As snowflakes fall from the sky, they accumulate on the ground, creating a blanket of snow. The amount of snow that accumulates depends on several factors, including the intensity of the snowfall, the duration of the storm, and the temperature. Winds also play a significant role in how snow accumulates. Strong winds can create snowdrifts, which are piles of snow that have been blown by the wind. Snowdrifts can be several feet deep and can make it difficult to travel. The weight of accumulated snow can also have significant impacts. Heavy snowfall can cause roofs to collapse, trees to break, and power lines to snap. It is important to be aware of the dangers of heavy snow and to take precautions to stay safe. Section 5. Blizzard conditions. When snowstorms rage. When snowstorms become particularly intense and hazardous, they are classified as blizzards. Blizzards are characterized by strong winds, low visibility, and heavy snowfall. To be classified as a blizzard, a snowstorm must meet specific criteria: wind speeds of at least 35 miles per hour, visibility of less than a quarter mile due to falling or blowing snow, and these conditions must persist for at least 3 hours. Blizzards can be extremely dangerous due to the combination of heavy snow, strong winds, and reduced visibility. These conditions can make travel nearly impossible and can lead to power outages, transportation disruptions, and a heightened risk of hypothermia and frostbite.